Today we're building a calculator. One that can do additions. Because that's the basic function of calculators. So far, we've mostly used signals to interact with doors and lights, in pretty straightforward, although sometimes very large circuits. But Fufe's large-scale calculator build showed there were other possibilities. And it was actually builds like mine and Fufe's that prompted Reforj to release a hotfix to reduce emitter lag. After seeing Fufe's build, I started wondering how you get from a simple circuit to something that can actually calculate. So I started experimenting. First with a 1-bit output. Then 2-bit. Then 3-bit. And that's where I started running into problems. The compact designs technically worked, but they were getting harder and harder to expand. So for this larger calculator, I will not try to make everything compact. Instead, I'll focus on keeping the structure consistent, readable and repeatable. The first thing we need for calculators is an XOR gate. Problem is, Reforj doesn't have an XOR gate. Unlike AND or OR gates, an XOR gate only activates when the inputs are different from each other. Which doesn't seem like much. But this is the first step towards doing calculations. So before we can build the calculator, I'll show you how to build an XOR gate ourselves. So by combining receivers, emitters, inverters and AND gates, we can actually build our own XOR gate. See? This works. Now, we can start building the ALF adder. And like I said earlier, I want to keep the structure consistent, readable and repeatable. So instead of compacting everything down as much as possible, I will lay out the first bit, which is a half adder, in a way that should be able to scale properly. And as we can see, the first bit is working. But we want a real calculator. And for that, 1 bit isn't enough. So we have to build a second bit. To do that, we will need to build a full adder. The first part of a full adder is the same as the one we just built. So let's speed this part up. We finished the first half of this adder. To deal with the overflow output of the first bit, the carry, we need to combine that with the output of the new half adder in a second XOR gate. This will make up the full adder. One thing I notice, the signal in the second bit is weak. So let's add repeaters to keep the output strength consistent. I ain't gonna lie, at this point, this thing is no longer feeling like just a couple of logic gates. It's already feeling more like a machine. Let's build the next full adder. This is where it will get trickier. But if we get this right, we should be able to easily scale further. Can't place the emitter here because of the adjacent receiver, so I need to move it back one block. The calculations don't add up correctly. I must have made a mistake in the carry logic. Let's find the error. still not right. I must have made another mistake. There. That reflector doesn't belong there. It should go here. Oh, I spotted another error in the same location. I forgot to connect a carry. Let's fix that. Okay, now it's working. So now we can just keep scaling the machine. We just copy paste the previous full adder, bit after bit. Oh yeah, this thing has become more than just a circuit. So let's test the calculator. This calculation doesn't add up. No pun intended. I think I have wired a carry wrong. Let's find the error and fix it. Let's retest the system. Yeah, that solved the problem. The machine now functions as it should. Now that the bits line up properly, the machine can finally do math. Additions, that is. And as you can see, this 8-bit calculator actually has a 9-bit output. Which means it can display values from 0 to 511. This build makes me think about a discussion on Discord. Should Reforj have a dedicated XOR gate? Honestly, I'm in favor. But I do think it should be something you earn. For instance, by unlocking it after building enough circuits with manual designed XOR gates. Not starting out with an XOR block forces you to understand the logic and get creative. But at the same time, after this build, I feel like I've earned a dedicated XOR gate. It compacts the design, kind of like how computer chips became smaller over time. Not to make builds easier, but rather to make new things possible. A few episodes ago, these were just experimental signal systems. Now they're doing calculations. And honestly, this is only the beginning. Because once a machine can calculate and remember the results, you can start teaching it instructions. So, if you want to see where this goes next, consider subscribing, because next time we're building memory so it can remember.